Hi, I'm William Malik, and I'm here to talk about your bit of security for August 22nd, 2024. We're going to dive into the deep end on software testing. Once upon a time, I led the build and test team for IBM Poughkeepsie, where we wrote MVS and the predecessor, that is, to ZOS and related subsystems. We had a lot of data about how effective our testing was. And it's important to remember to be very careful about what data you choose to pick, because as Frederick W. Taylor warned us, if you measure it, you'll manage it. Now, he never said if you don't measure it, you can't manage it. That's not only true, but it's not true, but it's nonsense. I have teenage daughters. Well, they're in their 20s now, and I certainly didn't use metrics to manage their growth. But the point is, be careful about what you choose to measure. One of the measures we had was defect detection rate, and that is the total number of defects found. Early on, it would sort of spike, rise very rapidly as you got more and more tests run. You'd quickly find a lot of the bugs. They tended to be easier bugs to find because testers are smart people. They want to knock off as much as they can before they have to downshift and get into the tall grass and look at the harder problems. So your curve would rise steeply and then it would kind of flatten out. And then you say, well, when are we going to find the next bug? That in itself isn't enough. You also need to know how hard, how difficult, how complex the problems you're solving. So the other curve that we'd measure is the aggregate severity of the defects found over a certain unit of time. And that would tend to have a sort of a mirror image. That is, it would be relatively slow, and then over time, you'd start solving harder and harder problems. If you scale these properly, you can effectively overlay the two curves. The horizontal axis is time, the vertical axis, is incommensurate, but at least gives you a good visual representation. We're spending more and more effort to get the next bug. And at some point, it can tell you maybe the cost of finding the next bug when you're doing testing this way is greater than the cost of finding a bug if we move on to the next test phase. And so you do so. You use unit test to shake out problems and individual code paths. That's where you do things like, make sure that your start and end conditions are correct, that you don't have buffer overflow, that you're not violating, storage rules or presuming an execution environment like privileged or root, which you may not actually have. When you move out of unit tests, then you go into function component tests, start looking at the behavior of a specific component, looking at variations on input types and so on. Typically, though, the routines you're working with are stubbed, they're not yet complete, and so you really are just looking at the behavior of a single module. Once you've got enough of those together, then you do system test, where you put the whole thing together and begin seeing it. Once you've got a running system, you can start looking at specialties like load and stress tests, like performance tests, like problem diagnosis, like user interface, like operator interface, those kinds of things. The point is that test costs are very low compared to the cost of fixing a defect once it's out in the wild and impacting customers. So what I'd like you to do is to take a look at how effectively you measure the kinds of testing you're doing and how you time that initiative. If you want more information on software testing, there's no better book I've found than Glenn Meyer's The Art of Software Testing, published a long time ago by a man actually who worked at IBM, and he was my boss's lead years before I jumped into my role. So I'm happy to say that I'm one of his, disciples, probably too strong a word, but, faithful believers. I've always had a copy on hand. I tend to give a copy away to people who are really into it. The book reminds us that you need a diversity of skills to develop solid software. It's tough making silicon behave. Good developers generally don't make great testers because developers are trying to teach the silicon to behave, and testers are trying intricate ways to figure out how it'll break. A good team makes use of a variety of skills. So think about your testing. Think about how much you spend on it, how effective it is, what feedback you get, and regardless of what development methodology you use, how to effectively integrate it to achieve high quality at low cost. And that's our bit of security for August 22nd. I'm William Malik. Be safe.